Alright, go in a room. Microphone. Alright, I gotta get a new microphone. Gotta do some new and better things, but until I do the new and better things, you'll just have to live with the old and crappy things and such. I'm waiting to see if this room loads, which it's doing, which is good.
Oh, I do.
Whoa, okay. So I figure I can do some comments, and then maybe I'll do, I have to rewrite my physics page, so I thought I would maybe add context to that and something like that anyway. So I'll get that loaded. And yeah, so on with the show, or something like that. Not much of a show. Yeah, sorry. I think it's just whatever. It's too many things to do. Complaint, excuse. God, this lighting is just horrible. Gotta work on that too. What is this? This white balance is just terrible. And this fucking camera. And that's just horrible. All right, I'll try something. Get rid of that. Whatever. Fuck it. That's the easy solution. All right. Let's see. Gravity has a speed of light? Question mark? Really? Question mark? Yeah, really. You think it's instantaneous, do you? If it was instantaneous, then we could theoretically communicate over long distances by subtly affecting gravity. Yeah, theoretically. Vibrations. Any vibration is going to have a gravitational effect. Any movement in something is going to gravitationally be connected to something else that was instantaneous. So in a sense, you could, let's think of some, like you could blow something up on the moon, vibrate the moon, and in a sense create a gravitational connection between anything that's you can detect gravitationally. So theoretically on Venus or something, there would be a subtle vibration that would exist and you could seismically detect it. So if gravity is instantaneous, then instantaneous communication is going to be possible. That's the implications of gravity being anything else but a force like all the other forces moving at the speed of light. But anyway, they probably have proof of it in some other, I'm sure they must have other mechanisms of evidence in the sense that they likely can tell from solar emissions or something else that it takes time for effects to reach us that are not necessarily just the thermal effects. But anyway, I don't want to speechify on the subject. I'm just saying that I would bet my functioning liver, that is, somebody can petition me to have my liver donated to them, immediately on request, if it's proven that gravity is instantaneous, which it will never be done, so I won't have to give my liver up. But anyway, I'm making the oral contract that if somebody really needs one, they can have it if gravity is instantaneous. Something like that. I would bet my life on it, in other words, or a lot of things. All right, QM, Timothy Richard, jerk. QM. So this idea of quantum mechanics, whatever that is, so the little magic box of stuff, some sort of idea of Heisenberg and Huygens and some relationship. Like I said, some parts of quantum mechanics, like I say, if you just take the Feynman part, Feynman diagrams, because that's a very mechanical thing. Okay, there's no real quantum mechanics involved in the sense that it's pretty much something goes in with a momentum, something goes out with a momentum, blah, blah, blah. There's a lot of conservation there and no real room for any kind of magical elements. Now, the probability stuff just has to do with a very standard probability. So it's obviously there's a consistency. So I could argue that you could call it quantum mechanics, that if I had a spring and I put tension on the spring and let it go, there's a certain rate at which it's going to pulsate, and in pendulums even. And so that part of quantum mechanics, again, is not under dispute, that there are reliable variations in outputs. But again, it's not because something's in a wave function. It's not because something's in some sort of non-existent state. It's a very consistent state. So again, the whole, whatever you're calling QM, again, I'd like to see you have the guts to actually define what you think quantum mechanics means in terms of actual functions of the universe, because I don't think you can. Anyway, QM explains specific results of experiment. Well, that's exactly my argument. My argument is it doesn't. Okay, their math doesn't fit in the single slit experiment, and Huygens is just a cheat. So their math doesn't work in single slit diffraction for light. Their math is not describing the actual pattern produced in the double slit experiment. It's producing a synthetic, well, it's sort of like this. But there's two patterns in the double slit experiment. The math does not produce anything resembling those two patterns. The probability wave has nothing to do with the actual pattern. So again, you can say it explains specific results. No, it doesn't. It's a vague sort of, kind of, but it isn't. There's nobody's applying anything called accuracy to any of this crap. They're just claiming that it's a fact when their evidence sucks, just as I pointed out with the lensing evidence. It's absolutely shitty evidence, and yet they are claiming it as an absolute proven fact, that it was proven back in 18 or whatever the hell it was, that the sun is lensing light. Well, it wasn't proven. The experiment was never repeated. And again, 15 years of the Hubble telescope, and we don't have any proof from the Hubble telescope of something being lensed by the sun's gravity. So more just bullshit. Just keep talking the bullshit. The Pope is right. He's God's representative on earth. Okay, you just tell me your religion, and I'll tell you, you don't have any evidence for any of these claims you're making. You're just claiming it because a lot of other people are claiming it. And so, yeah, you're a bunch of Catholics, and you're going to tell everybody else what to believe. Well, fuck you. All right, the results lead us, which is funny, to the strangeness of QM. Well, again, you're saying it's strange. I'm saying it's not strange. It's a fraud. Okay, it's functionally inaccurate. It's a misinterpretation of data, and it's a misinterpretation in a way that can't be justified, in that the evidence absolutely is at best described as weak. Not strong evidence, weak evidence of anything called strangeness, anything real in terms of a strangeness. The only thing strange is your bizarre interpretation, your unwillingness to recognize that there's probably a mechanical explanation. Instead, you go for a religious explanation. The magical photons know how to split in half. Most physicists, well, again, irrelevant, would prefer a simpler picture of the world. Well, most physicists, in my opinion, have been brainwashed and obligated to accept the math. They've been told you're not going to pass the test unless you do it our way. There isn't any complete other alternative theory, so you're stuck with this one that we've all invested in. So this interpretation is the interpretation until somebody can assert a better interpretation. And the truth was that these other theories were out there, but they always were so quick to criticize them and dismiss them that they didn't realize they were dismissing the actual truth. And this is made glaringly obvious by Feynman's dismissal of Lesage gravity. He dismissed it with a silly argument about raindrops, not recognizing that even in the 300-year-old interpretation of, a presentation of the theory. They were called ultra-mundane particles. So not exactly something you would call raindrops. But again, just keep ignoring. But experimental results back us into a corner with that regard. Well, again, I'm saying the experimental results are glaringly inadequate. The evidence is, like I said, the two-slit experiment and the single-slit experiment demonstrate weak evidence of any kind of wave function, any probability, blah, blah. It's annihilated if you do the single-slit experiment honestly with light. All the bullshit goes away. And the same is true for the lensing arguments of galaxies and the big universe, and especially solar lensing, which hasn't been. The experimental results don't back you into a corner because the experimental results are incredibly weak. It would also be nice if you watched the whole video. I have watched the whole video, so fuck you until dead. And then commented instead of flipping the camera back and forth. Well, my style of doing videos is my style. You apparently don't have any style, and so I don't think you have any right to criticize. Timothy, let's go watch your, see if you have any style. Go see if you have a fucking, no content. So, yeah, shove that bullshit. Anyway. Because you end up correcting yourself because you don't listen to the whole thing. Well, again, my corrections are minor, and sometimes people will say something I didn't anticipate, but in most cases, when I play most videos, they're videos I've already watched, so I don't know exactly the context of this video you're referencing, but regardless, I'll defend. You want to claim that there was something left out, you want to claim that there was some point not made, I'll say bullshit. So why don't you just quote some sentences out of the video if you think I was wrong about something, and I'll correct if I was wrong. The channel's called DraftScience, by the way, asshole. Apparently you can't even read that part. But regardless, if I made a mistake, I'll correct my mistakes. But the point is, I think I've addressed their argument, jackass, and I've done it over and over again. None of you assholes have come back with anything. So again, defend Huygens. Defend a principle in physics that's only applied in one circumstance to create a fake second photon. Explain how Huygens isn't doing exactly that. It just creates a fake second photon that doesn't really exist, and they only do it in the one. How can you have a principle that you only apply in one circumstance? That's not a principle. It's an abuse of the word principle. They couldn't call it a law, obviously, because obviously they don't believe Huygens actually happens, or they would have called it a law of physics. Anyway, this is not helpful to you. Well, fuck you, and I'll figure out what's helpful to me. Also, please provide context to your statements. Well, whatever that fucking means. There's 300 and something videos here. I think that's called context, jackass. All you are doing is watching Nima make a statement, and you just negate it because it doesn't mesh with you take on Nima. Imagine the particle at rest. Well, again, the whole argument is that the fact that they have imagined particles at rest and not recognized that forces are never at rest, and that's what E equals mc squared essentially means, is that forces are never at rest, and that matter is essentially made out of force, and that it's not at rest internally. There is no rest state for the fish actually making up the schools of fish. These are, I think, perfectly cogent arguments that a school of fish can appear to be at rest, but obviously the fish in the school are not at rest. All right. All you're doing is watching and making negate. Okay, imagine setting up a thought experiment. Well, again, these thought experiments are frankly something that's gotten physics into a lot of trouble because they think of these experiments in ways that are preposterous, as if you could move a spaceship half the speed of light and it wouldn't be affecting how light travels. Of course it would. And you immediately just state that particles are never at rest. Yeah, I just point out that if they understood that that's their fundamental flaws. They don't recognize the existence of the biggest force in the universe, gravity, and they don't as a real force, and they don't recognize the fact that it is, in a sense, the creation of all the other forces. And they do this because they don't recognize that there is a source of energy in the universe, that they have converted into bent space and taken out of the universe. And that's why this rest argument has to be their argument. It's because they have misunderstood how the universe functions. That may be true, but Nima is constructing a toy model of the universe in order to elucidate correlations between those models and cosmological observations. Well, again, I'm going to argue that it's through those broken models that they've misunderstood the function and misinterpreted things like redshift. They think redshift is a function of space when it's a function of the matter, metabolism. A model doesn't necessarily have to perfectly mimic reality. Well, frankly, it does have to perfectly mimic reality if you're going to use it as a foundational argument. And the joke here is that mock gravity does perfectly mimic reality in the sense of the gravitational effects work perfectly with a particle gravity. And the only point you have to fix it is when you start giving things velocity outside of the gravitational relationships, and then you have the drag problem. And again, the drag problem is eliminated if you understand doing it kinematically, or through recognizing the existence of kinetic non-frictioned reactions that fish don't break into little fish. Once you recognize that, then you don't have any drag problem. And it can't be applied to reality in a one-to-one manner. Well, again, there's no point in doing models that aren't that aren't proportional, at least. So I don't care whether it's one-to-one. The point is it has to be it has to parallel it in accuracy. But it can help us to understand us again, understand some of the strange things in the universe by examining pieces. Well, again, they're not strange once you once you understand the truth, just as the strange animals created by evolution are no longer strange. It no longer seems bizarre that giraffes have really long necks, and there's not a whole bunch of animals with a whole bunch of different sized necks and all of that kind of crap, because once you understand how evolution works, you understand that all of those intermediate species are no longer exist, and that they all existed in very small, punctuated tribes of organism. And it wasn't until they got the long neck that they became very successful, and that's why there's giraffes today. That the intermediate species were not very successful, and that's the case in evolution. So there's a strange circumstance. Why aren't there a bunch of missing links? And the answer requires you to properly understand the theory. And my argument to physics is they haven't properly diagrammed the fundamental particle. They haven't properly diagrammed the energy conversion model. And so therefore, all of their perceptions of the strangeness, it seems strange because they're not they're not looking at it with clear glasses. They're looking at it through crooked ones. Can't just toss out QM because you don't think it's right. Well, of course I can if I have an argument why it's not right. And I've explained why it's not right is because it's premised on almost flamboyantly silly conclusions drawn on pitifully poor evidence. I mean, the two-slit experiment is pitiful evidence of photon splitting in half. It's pitiful evidence of Copenhagen and many worlds and all the other silly interpretations. It is rubbish as evidence. And the fact that you people don't have the discipline or even the enough respect for science to admit the evidence isn't nearly good enough for a conviction, and you've basically broken the law of physics by making these bold assertions. There's gravitational lensing based on an experiment never successfully duplicated. And that's the truth. It's an experiment never successfully duplicated, and you proved okay, that gravity moves light. No, you didn't. All right, so, yeah. All right, I think there needs to be a third. All right, this is Phil Clayton. I think there needs to be a third component measured. Oh, let's see if there's any comments so far. Always want to keep the little commenters happy, right? Good, nobody. Only 3 people watching. Excellent. Yeah, fuck. Whatever, doesn't matter. I'm doing my thing. You can do your thing. The rest of you, well, the people that can't hear me, yes, go about your business doing your thing while I do mine. Anyway, mostly. Was a little late tonight, so I probably threw everybody off, right? Yeah. I think there needs to be a third component measured by dropping a third ball at free fall simultaneously with the other 2. Well, you can't really do that in the experiment. The experiment isn't really dropping things. It's momentum going sideways. So now he's talking about the circular gravity thing, and I plainly explained how it works. I plainly explained that velocities, when you change something's velocity, it requires energy. A force has to change something's velocity, and so if something's going to change, a force has to act on it, and if the thing itself has to generate that force, there's no external thing like gravity that's freely pushing you in a new direction, then the thing has to generate the force to change its direction, and therefore it has to lose velocity because it has to convert its velocity into the force that will move it. And yeah, so I've totally explained this. Okay, your velocity will be fundamentally different if you're changed in your the change in your momentum is being caused by an active external force or just a material obstruction. If it's just a material obstruction, then you have to generate the force to change your direction, and that will have to be extracted from your velocity. It's not that complicated, and it fits the reality. So cars going around curves have to dig in, have to gain traction to convert their velocity into a change in velocity. So that's what they're doing. It's not more friction, it's more traction, and the traction converts force into force. And again, if they were in gravity and being turned, then they wouldn't have to apply that force. The gravity would apply the force, and therefore they could maintain their original velocity. There would be no degrade in their velocity. So orbiting objects don't lose velocity when they become orbiting objects, and objects in some other circumstance where an external force or a string or some other tension doesn't provide the force for the change in direction, the velocity will be converted into the change in velocity, the change in direction. Anyway, to take into consideration the atmospheric and gravitational constant that defines the conditions of the straight line path and the circumferential, I don't know what it meant, pathways. It just doesn't matter. I mean, the simple diagram is you just look for where the forces are. Now, the rolling ball has force. Nothing else in the experiment has force. Therefore, the only place the force for any change in direction can come from is the ball. So the ball has to provide the force for the change, and therefore it has to give it away in terms of a degrade in its velocity. It will do justice to the frictional lag, however. Well, the friction is sort of irrelevant as a part of the friction is a tiny percentage of the overall energy in the experiment, so you don't even need to really consider it. It's not a player. But how interesting, considering the photonic curvatures when unwrapped into a straight line path. Well, this might be about the stupid that stupid Ferrel cell thing, would give the true speed of light. Now, there's only one speed of light. It's already been measured. Okay, light always travels the same speed. It just doesn't always travel a straight path. So obviously, if you change the path the light is traveling, it will appear as if it is taking longer or is moving slower, but the truth is it's moving more distance and therefore appears to be moving slower, but it's not really moving slower because it's just traveling more distance. Yet all matter would not exist in such a state of light. Well, that says you. Cool vid. I don't really go for that lingo. Dig in it. You know, don't care for that. Groovy. You want to just say groovy. Thanks. Anyway, thanks, but yeah, I don't need the extra little blah blah blah. So, all right. So I think that's about it for new comments, which is kind of dismal. As a, not much help. Yeah. So anyway, so I figure I'll just read some of my old thing and point out where I got to fix it. Just because I have to do it, and so I might as well get myself into it a little bit. So abstract. At some point, I see this part I like. This little opening says it all for me. At some point in the early 1900s, the science of physics committed itself to a confused dualism model of reality, where things could be more than one thing. Yeah, that was really dumb. Things can only be one thing. So let me write that down. Yeah, it's push, not pull. Yeah, I'll have to put that in here. That's probably an important one. But yes, everything is just one thing. Nothing is two things. Yes, or three things, or five things. Everything is just one thing. Anyway, the controversy of wave versus particle became the compromise of particles waving, and with that, physics waved goodbye to a rationally comprehensive model description of material reality. So that is just a nice, true statement that physics made a huge mistake in not figuring that first it has to commit to one or the other, and clearly, of the two models, it just makes sense for simplicity first, that you just can't get simpler than things banging into things, fish banging into fish. And this whole idea of turning the fish, the simplest thing in the universe, it's sort of stupid to say, well, look, we have these two competing things and we don't really have hard evidence for one or the other. And then to jump on the side that is so much more complex in terms of explaining it. I mean, as soon as you start saying there's an electric field and a magnetic field, well, then you have to explain how this field, what does this field exactly made of? What does it do? How does it function? And how does your silly little photon thing that you're saying is not a thing, how does it do this waving in this medium that it's waving in, where the the wave doesn't spread and it doesn't obey any of the other mechanics of waves? I mean, it just doesn't. I'm just saying. I mean, the fact of the thing coming out was a ton. The thing hitting the other end is a ton. It's just kind of silly to sit there and pretend it turns into a wave in between. And the physics just should have done a little more work to make the particle thing work. I mean, it wasn't that broken, and they just rejected it out of hand for some dumb, stupid, idiotic reason. And I kind of blame Einstein because, I think he really did. He was so close, and he, and his own mistakes, kind of closed the door. And then he got stuck with his own mistakes. I mean, bent space was a real big mistake because, that just took the biggest pile of quanta in the universe and just shoved it into this other dimensional space that we can't access in any kind of rational way. All right, anyway, it is proposed that the universe in substance is just made of one thing. Let's call them quantons, or happy fish. That are always moving and have no other property beyond an orientation of polarization. Now the truth is, that's the truth. So that's okay. I remember I changed this because I had frequency in there, but frequency really isn't a property of the quantons. It's obviously a property of something that's emergent from their polarization. So it's not really, it's just a function of the period with which they arrive at a location. And that's not really a function of the quanta itself. These quantons fill space, matter, and energy, and are in essence all there is and all that is. And that's the truth. The only thing moving in the universe, really moving, are the quanta, the force, and everything else is just like a school of fish, an illusion. It's just a byproduct. It's an emergent property of the function of the fish. The school doesn't make the fish make the school. So obviously that's all good. All right, these quantons, right, and that's all there is. When trapped in circular orbits, so that's I'm going to get rid of. So I'll kill circular orbits. That's not correct. I mean, they're in patterns, but I think the magnetic patterns of atoms have a lot less motion in them than physics believes. I think they've misunderstood the magnetic attraction, and they've just made assumptions about movement because the school of fish is full of quanta, it's full of energy, and so they're recognizing its energy, and they're assuming its energy equals movement, and it doesn't. All right. When trapped in circular orbits, we call them matter. So when trapped in pattern, see, that's even wrong too. So when trapped in circular orbits, so the quanta are never trapped. So let me write that down. I mean, they're never in a circle. They're never in a pattern, so to speak. They can be trapped is the key thing. So I have to think of a way to say that. They're trapped, but they're trapped by the force. So the quanta are just they do the back and forth thing. They really don't do the circle thing. But the back and forth thing can make a school, and the school can do the circle thing. All right. All right, when trapped in circular orbits, we call them matter. When they arrive at a precise time interval, we call them light, photons, electromagnetic radiation. So that's correct. When in their most common condition, not matter or energy, they are force and instigate through their ability to transfer directional identity, all material movement, gravity, magnetism, electric charge, nuclear force. So in a sense, I'm saying that's absolutely correct, but I guess I should sneak in the word gravity somewhere earlier, maybe. When in their most common condition, which might be just called gravity, not matter or energy, they are force. And the fundamental force is gravity, and you can polarize gravity, and you can polarization at a frequency would be light. So light is just gravity that's polarized at a frequency. At the real working level of the universe, the smallest bits are just kinetically banging into each other and exchanging direction. So that's correct. The fundamental function is that simple, and combined with the probability of pattern creation, orbits. See, I'm going to get rid of that orbiting thing. The incredible complexity of the universe as we experience it can be filtered out of this simple function. So that is okay-ish, except for the orbit word I had in parentheses. Get rid of that and use some other word for it's not so much, again, it's not the pattern is a consequence of the exchanging of polarization. So that's it's not a static pattern. It's a an active pattern. I have to come up with a way of saying that. Yeah, I have to think on that one. Let's see. Maybe I'll see if the comment thing works. Probably should work. There's just nobody commenting. That's probably it. Yeah. Yeah, but I won't bother testing. Anyway, all right, where was I? Okay, filter out of this simple function. There we go. All right, the kinetic paradox. So this is the simple thing where I'm explaining the two differences and, you know, the difference between like and not like. Yeah, I don't have a drawing of all blacks to compare it to, so I guess I could do that to make it more easier understood. An kinetic interaction between indestructible hard masses with a velocity momentum, there is created a paradox of sort, and the interaction can look either like something or nothing happened. That's okay. Viewed one way, the objects will have their velocities travel through each other, and the universe after the interaction will look exactly like it would have if the interaction never happened. Viewed another way, it can be understood that the masses completely interacted and exchanged their directional momentum, and the resulting universe is now substantially changed in that the objects have individually substantially exchanged directions. All right. So, yeah, that's okay, but I have to get to the polarization thing. All right. The truth is, purely kinetic interactions of quanta are a complete exchange of identity. The quanta that make up the universe are at regular rates experiencing this change in identity, and this creates opportunity for the collection of identity and patterns and forms. I don't think I go with forms. I'll just say patterns. In geometry, a circle can be understood as a rounded square, a collection of 4 90-degree turns. In a mass of random kinetic interactions, it can be understood to be just a matter of probability that there could be 4 interactions in a sequence that may take an object back to its starting point and create, in essence, a circular path. So I don't know if I need this circular thing in here. The idea of the thing that needs to be emphasized is something can appear as if it doesn't have any velocity because it doesn't go anywhere, but it's moving internally. So obviously the pieces can be doing all kinds of stuff, but the point is they never escape a field, a portion, an area of field. They'll never be able to get very far without being forced back in. And it's that idea of pressure, a field of pressure, that creates this bubble. I was thinking a little bit about that. So, you know, I know the gases are a little bit tricky, but water is kind of interesting in space. And it seems kind of curious that there isn't any, as far as we know, any little blobs of, you know, just like the size of an elephant. Just pick something, like of a blob of water in space. You know, they got shot off because some meteor hit and a blob of stuff, you know, went out and it just condensed, and it's like a blob just sitting out there of something like water or some other substance. And it might just be because of the heat problem. You know, it just keeps getting thermally evaporated, and then it breaks apart, and it never can recollect because the little bits are all moving, and they escape the pressure field as they get outside the area. And once you go outside the area, then they're going to drift away rather than in. Something like that. But anyway, it's just something I thought of. I don't have anything extra to add on that subject. Just something I thought of. All right, well, anyway. It is a quality of the physical universe which enables such patterns to become durable that is responsible for all that we know as matter. So the durable part would be the existence of electrons, protons, and neutrons. These are the key elemental force masses, force mass. I need a way to describe an elemental, but not a particle. Elemental force mass. Let's see. It's a school of fish, but I need a better word than school of quanta. I want to use something a little more scientific than that, a little more explicit. But that's, part of this whole language problem is that, the word particle is being used to describe things that aren't themselves truly particles. They're not made of fundamental particles. They're not a fundamental particle. They're a what's the word I used before? They're a not expression. Damn, I really hate this getting old thing. I got to get this done soon because my brain is turning to shit. Or maybe I'm just really, I'm doing way too many things. They're an emergent particle, maybe. An emergent body. Yeah, I have to think on that. Some sort of better language. All right, anyway. Okay. Patterns become durable. That is responsible for all that we know is matter. The material universe is just quanta in circular orbit. So yeah, I'll get rid of that because that's not accurate. It's just quanta in, let's see. See, it's moving in pressure, restricted, or controlled pattern. But see, it's not the quanta itself isn't in the pattern. It's just that polarization that's in the pattern. So I have to get to the polarization part. That's not really you either follow the polarization or you follow the momentum, but you can't follow both. And that's one of the little tricks here. If you start mixing the two, it's like not properly identifying what a particle is. You start breaking the momentum arguments. So anyway, so the material universe is just quanta in circular orbits, and as those objects begin to orbit each other, material structures are formed. So yeah, they really just don't, I think, do all this orbiting thing. They just do this magnetic thing. They're magnetically tied by pressure, attractive pressure, which is really repulsive pressure, but anyway, by uneven pressure fields that force them to be a distance from each other, and they can't get closer because of this other force that's blocking them. So it's a mixture of force dynamics, something like that. I don't know if I'll never be able to read this later. Force dynamics. It'd be very nice if I was literate, I could spell. Anyway, and as those orbits begin to orbit each other, material structure, the very big universe we see, in the very big universe, we see the simplicity that is also the very small universe, but hidden from our perception. So parts of the small universe do duplicate the big universe probably, but certainly not. The small universe is controlled by magnetism. The big universe is controlled by gravity. With a simple way to identify the distinctions or differences. Yeah, simple way. All right, there's a comment. How do you read physics books? They're so boring. I don't actually read them anymore. But yeah, it's you got to learn the math, and that is irritating that it's all about these force relationships, and so that is sort of important because you have to sort of understand the force. But what I'm sort of arguing through this, once this new physics gets in there, though, a lot of that math is going to get a lot simpler because it's just so obvious that you're just measuring a volume of stuff that has a very conservative, ruled, very mechanical straight line path. So it's just adding up. If you see a school of fish moving, you can rationally deduce that it had to absorb fish moving that way. It couldn't move any other way. It had to actually absorb an excess number of fish moving the way the school is moving, so to speak. I mean, obviously fish are not quanta, but I just mean the argument would be that if you model fish as something that only moves in a straight line and has a constant speed, well, you don't even have to do the straight line thing, just to understand that obviously the only way it can move is that it has to have fish moving. And so if you just use it for a very short, if you just use the fish model for a very short period of movement, you don't have to do the complexity of the fish changing directions and then continuing the direction and all that kind of stuff, because that's explained with something else. I'm just saying the force dynamic is just so obvious. Something goes in, something comes out, and it's Feynman diagram kind of rigid and simple. Anyway. Are you a lecture type of guy? Yeah, well, the lectures are, I'm an experiment kind of guy, ideally. I mean, seeing is believing. So yeah, the experiments are really fun. But even having an experiment described with its results accurately is good. And seeing that's what they just don't do enough of, is when they actually do these experiments, you can really see what's happening, right? So when they do the single slit and with a variable opening, you can see what's happening. You can see that as the slit gets smaller, the pattern spreads out, and it's the same pattern, it's just spreading out, it's just magnifying, and it becomes so much more. You can see the fact that when you see it as an equation, they draw it from like, oh, okay, the slit's at this distance, the very small distance, and where because it's so magnified, you're only seeing one tiny piece of the pattern. So only one tiny piece of the pattern is showing. And so they'll draw something, it looks like a penis, with balls, and they'll say that's the single slit. But that's only the single slit at a very tiny gap. If you widen the gap, then the single slit becomes 30 or 35 little bars. It becomes very reminiscent of the double slit pattern. It looks a lot like it, except it doesn't have the extra bulges in it. So it's cleaner. A clean linear line of little bars is what the single slit will produce at its widest aperture, wide enough where you don't dilute it by having it too wide. The wider you go, then too much light goes in the center and it just washes everything out. And also the pattern gets very small, relatively speaking. So anyway, all that can be, so I'm just saying experiments are the best if you can get to the real experiment. But, a lot of experiments now are highly technical, so they're not very much fun because you have to trust that their clock can actually do what they say. Oh, this device can see the same photon, so we shoot a photon over here, and then we can detect the photon we shot over here, and sure you can. So I mean, the experiments are a lot more complicated than something like the double slit, where it's a mechanically simple experiment. So there's not as much potential for shenanigans, and physicists making claims that they can't defend, in that we can see photons, which they can't do. All right. And in the big universe, we see a mechanism we call gravity hold the solar system. No, I think this is the new part. Yeah, the universal glue, kinetic field pressure. So we'll see, I think this is going to have a couple of big mistakes in it, but anyway. In the big universe, we see a mechanism we call gravity hold matter in patterns and make solar systems and galaxies. On the level of the very small, the very same mechanism holds quanta in patterns that become matter. Okay, so it's not the same mechanism. It's the mechanism is magnetism. It's the same force. It's just that it's been magnified by polarization, by filtering for polarization. Just as space between planets is the same as the space between atoms, the force holding these things together and pushing them towards each other is fundamentally the same. So that sentence is okay. It's fundamentally the same force. Magnetism and gravity are fundamentally the same force. It's just one is thick with polarization and the other is thick with chaos, randomized polarization. The universe isn't two places, big and small. It is one place with one set of fundamental properties. So that's true. The only universe that exists is the small universe. So we're all the way back to the fish argument that the big universe is, this million scale thing. So I take one fish and I go a million times bigger than that one fish and I have an electron. And I go a million times bigger than that electron, I got an atom. And I go a million times bigger than that, and I got a compound, whatever. Probably not that. It's probably not correct. It's something else that's in between. I got the moon or something. And then you go a million times bigger than that, you got a solar system. A million times bigger than that, you got a galaxy. It's that kind of scale difference. So the fish are infinitesimally small in terms of the gazillions of fish that make something like I said, even the apple earth argument, right? An apple is to the earth what an atom is to an apple. Now, fish to an apple, fuck. That's a whole nother earth to apple scale, even smaller. So that's how far from the fish we are. I mean, this universe we exist in, as big as the big universe seems to us, that's how small the small universe is. I mean, it's just so far away, the actual fish. It's impossible for us to see them, so to speak, to relate to the grotesque volume. Again, I mean, just to get the atom to the apple is like the apple to the earth. And again, to think that the atom is already an apple earth worth of fish. Really, 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 really far away from the real universe. I mean, we're just so oceans and oceans and oceans away. Anyway, yeah, it's almost like physically us to ourselves. I mean, if I say you have 100 billion neurons in your brain, right? I mean, how could you even contemplate 100 billion neurons? I mean, it just doesn't. You say, okay, yeah, it's a lot of little roundy things inside my head, but 100 billion. I mean, that's that's a lot of stuff for 3 pounds. 3 pounds, that's 100 billion neurons. That's a lot of fucking neurons. So, it just gets a density argument. It's just hard for us to see the real universe, even imagine it, because it's just so dense. I mean, 100 billion just to, understand cells. So how can you do that? I mean, I can only understand cells as like, okay, cell here, cell there, cell. I can't do 100 billion cell. I can't image it. I can't imagine it. I can't in any functional or decent way mentally model 100 billion neurons. And that's a problem. And you have to know that if you're going to do this science thing, you have to realize there's perceptual problems that you can't be fooled by. Just because you can't see it doesn't mean it isn't that way. Just because your brain can't model it, or imagine it. Doesn't mean it isn't the way it is. Right. Okay. On the level of very small, the very same mechanism. Okay. Where the hell was I? Space between atoms is holding atoms. The universe isn't two places, big and small. It is one place with one set of fundamental properties. Okay. So that's a very eloquent, I think. So I like that. Imagine starting with a clean slate, a great expanse of truly nothing. Now introduce a very small something, a dense field of simple little bits that have a short list of simple properties. Okay, 1, they are in constant movement in straight lines. And I would add, they are stuck with this speed thing, the speed of light. The speed of force, that's what I'm going to change it to, the speed of force. They are shaped taller than they are wide. That's what we're going to use for polarization. They're a frisbee. When they hit each other, they exchange direction with each other and do nothing else. But the interaction takes a moment of time. Okay, I don't think I'll mess with the interaction taking time because that just gets messy. I think it probably does work that way, to tell you the truth, but I don't think it's it almost ends up creating the ether kind of idea where everything is just a location, and the locations just bang into each other, and it takes a certain amount of time to bang and then the other thing to move, and that's what time is created by. But I don't think there's any point in getting into that. It just opens a can of worms I don't need to open. So they don't really, they exchange either. You can perceive it as they either are exchanging momentum or they're exchanging polarization. But yes, it's one of those two things. They exchanged the direction they were moving, or they exchanged the polarization, the suit of clothes they were wearing. So they exchange hats or clothes, or however you want to, jackets, however you want to describe it, or you see them as exchanging direction. What they're really doing is exchanging the clothes, so that's the truth of it, although it can look either way. In modeling it, you don't need to know which one is actually happening for the model to work, in other words. Consider the implications of such a field in motion. Perhaps you can understand that it would create a kind of even pressure, that every point in the field would become a point of intersection or convergence, effectively bombarded from every direction. If you were to place a still object in any position in the field, it would be constantly jolted by pushing force coming from a constantly changing direction. Okay, and so that's getting to the beginnings of gravity, but that's an argument I think I need to make more extensively, in the sense that this whole convergence idea, the idea that from every point in space, everything's converging. So every single quanta of field location, every pixel has exactly the same energy pushing, going right for it, heading right for it, heading right for it, heading right for it. That's what an even pressure field is. And what changes the force dynamics is when you put two things next to each other and they start absorbing force that would have hit the other guy. That's when you end up with this thing we call attraction. Yeah, so that will be explained, no doubt. All right, need a Colosseum of Physics. I noticed that you received more discussion back in 2012 compared to now. Yeah, well, it wasn't. I mean, you should have noticed that the discussion wasn't at all polite or reasonable. So some of that discussion went away because I got sick of being trolled by assholes who just kept, they just keep posting links to some experiment, and then I would debunk it and explain it. And then they just post another link and I have to debunk and explain it. And then they just post another link and I have to debunk and explain it. You're just like, oh, okay, so I never get to win the argument. You're just going to keep, changing the goalpost. And so if I debunk this experiment, you just give me another one, another one, another one, another one. So we're just going on this endless chase for this proof. And some of it was very time consuming, like, to research all of the Edinburgh style lensing experiments is, you got to read all this documentation, go through all this crap, and then you find out, unless you read it, the experiment, especially the one I think they did in 56, they said that, oh yes, there is, our conclusion is there was gravitational lensing, but then you have to read all the way through the document to find out that no, well, their experiment was affirmative in their opinion, but they concede that the experiment doesn't escape the margin of error. So the experiment doesn't have any scientific value, even though they claimed a result. The result they also admit doesn't have any value, but they don't put that at the top of the page. You know what I mean? So you have to go through the whole document to find out, oh, they never escaped their margin of error. And that's the bullshit. So that's very time consuming. So obviously I don't want to do that all day long to satisfy somebody who will never concede that I made the valid point, that I have debunked something, and they'll never concede that it matters. So I mean, I can keep pointing out how Huygens is a complete piece of shit. Nobody's presented me any evidence that Huygens represents a real phenomenon, that waves actually do produce an infinite number of little waves in front of them. Nobody can rationally defend that as a physicist. An infinite number of little waves. How can you have an infinite number of anything in this confined space? Physicists can't believe that. If they believe that, then they have to change their physics. So it's an undefendable position. I've never heard any defense of it, and yet they will not concede that this is a big problem, that this experiment is used as justification for the whole foundation of quantum mechanics as it is described today. And it is a fraud. It's nonsense. It's rubbish. It's shit. It's crap. It's garbage evidence. Anyway. All right. Okay, so now introduce a second still object close to the first. So we have these objects in space. So the idea is to see one object and then another object and see what happens to the pressure field around them. And the obvious thing is if you understand that it's a straight line pressure like light, it only goes in straight lines, doesn't bend around the corner, that it can't fill the voids. So all the shadows, essentially anything that casts a shadow, is really casting an absence of pressure. And so wherever you can see where a shadow would be produced, you could understand that that shadow represents a lack of pressure. But anyway, I probably explained that better this than I did then. Perhaps you can understand that a single object will be profoundly affected by the other object's presence. Now the straight line pressure will not be able to reach all surfaces evenly. The circumstance invents the shadow, and with it imbalance, and with that movement. I think that's pretty good. Though through this mechanism, the material universe is pushed together, not so much by the presence of force, but by the shadow of absence. Oh, I do like that. So yeah, it's not, and the absence of the force is, I have to restate that, is that it's not the absence of the force actually, it's the absence of the polarization. The polarization is what gives it weight. So if the frisbees are going this way, they don't have any effect. If they're going this way, they have complete, they always affect the object. So if you think of everything having its own grid work, bars, only the frisbees are going the right way is going to get through the bars, and any frisbees not going the right way can't get through the bars. And that's basically the function of all matter. All matter is basically arranged in bars, and it matters which way the frisbees are going. yeah. All right, colliding with the technicalities. I don't know if I want to get into this piece, because this is really gnarly, and I really have to do a lot of editing there. But I'm also getting tired, so I might just cut this short. Not much commenting going on or anything happening anyway, and blah, blah, blah. I just wanted to get back into the routine. Really hasn't been anything to comment on. The Ken guy did another magnetism video, but it was just, again, it's just pointing out the obvious, which is, look, I used a kid's toy, I put a magnet on it, and you can see the little pins pop up, and the faster I move the magnet, the more pins move up. And that was just really bogus, right? Because we know that velocity is, it requires me to impose more force to move with speed. And so speed is more force in these circumstances. So if I move something faster, the faster I move it, that means I have to apply more force to it to get it to go quickly, to do that transition from one position, one state to a new state. If I do it with velocity, that velocity will require more force than if it goes slower. In the sense that all right, see, that's the tricky part. It's not really more force, but it's more yeah, well, I'll have to go. Yeah, see, it does raise an issue. I mean, in the sense that I'm just saying that the fact that exists, the fact that he was making something of this, as if there were, go basing it on how many pins moved, when it's not about how many pins move, because the reasons why the pins are moving is because of the dynamic of how you're applying the force. And so, of course, a light bulb won't go red or won't produce any light if I just take the voltage and apply it over a half-hour period at a lower voltage. There's no light, because you're not forcing the issue. You're not forcing the issue. You're not making the kinetic happening happen in the way it has to. It's like dominoes going faster than dominoes can flip. You can't make the dominoes flip faster. So it's the same kind of argument, except in reverse, in the sense that the faster you do some things, the more likely you are to fracture like a glass. So if I apply pressure slowly, the glass will accept the pressure. If I apply it quickly, it won't accept it. And that's all that's taking place. And he's making it into some other argument, that's just bullshit. Trying to imply there's no conserve. There's trying to. I don't know what he's trying to imply actually. But yes, I mean, even the guy in the comments did explain it to him, and he still, didn't pay any attention. Just keeps using these stupid terms, the plane of inertia, just absolute crap. An audience with at least one competent physicist is all you need. I feel like this discussion is good, but it's going in circles. Well, whatever. I'm sorry that you feel that way. I mean, I understand the redundancy, but yes, I do need to. Even back in like Newton's time, they had these little theaters of, meetings, and you go to a meeting and you could argue this shit. And it is kind of irritating that I can't just show up at a meeting and argue this shit. I can't defend this new theory in any kind of environment, where I'm obliged to be dealt with. And there is the peer review system, but again, it's just so closed that you just can't, unless you're, I can look, I can pay, but I just don't want to pay, obscure publications, and have no guarantee that I'm going to get the review I want, which is where they actually have, somebody has to put something on the line. That's another thing that's really quite disgusting about peer review, is it's all anonymous. These guys aren't accountable. And that's a huge flaw in my opinion. The people doing the reviews should be paid, and part of what they're going to get paid for doing is putting their reputation on the line. I mean, they should have a reputation to lose. And that part pisses me off, that I don't have the prerogative of having the intimidating factor of somebody having some fear that in the future I'll out them and make them look like assholes. I should have that right to give them, let them know to be at least serious enough to recognize that they better be careful in how they wave their dismissal hand at things. So, but anyway, yes, it is a fair point that I have to elevate this to a new game. But like I said, the good news is is that I'm much more, I have a much solider theory now than I had 6 months ago, even though I was quite confident 6 months ago. I mean, the basic principles, as I've just pointed out, haven't changed. But the truth is that I've got this electron proton thing, nailed. And that's the whole function of all the material universe, really. And, that's a huge component to have right. And recognizing this idea that you can't follow both momentum and polarization. You either follow just the polarization as it changes, or you follow momentum changes, but you can't follow both. If you follow both, you'll end up with too much energy. Well, you'll end up very confused. Yeah, because the fact is the bits in the true universe, the bits are the fish always go in straight lines forever in one direction, and the truth is they only just where like a bit's going through me right now, it's going to be polarized like my matter, and then it's going to be unpolarized as it comes out. So it's only going to be polarized while it's inside of me, and then it's going to be just going on its way. But the truth is, it's going to look like some other bit exchanged momentum with that bit. So it's going to look like there was a momentum change, but there really wasn't. It was just a polarization change. Something went in and something went straight out the speed of light. Nothing ever changes in that sense. And it's just the polarization that changes. Everything that is just is because it's filtered polarization. So if you thought about the big field just being a bunch of random colored fish, what the universe did was all the random colored fish, say all the blue fish ended up becoming electrons, and most all of the red fish ended up becoming protons. And there's still some in the field, but very few. So two kinds of fish, this one and this one, got filtered out into blobs, and the rest of the fish are still out there. It's that kind of thing. But anyway, I digress. Out of curiosity, what drives you so strongly to physics, even though it's all ego and meaningless in the end? Well, you can say that kind of shit. It wasn't all ego to start with. I mean, certainly now, you can't help but have some sort of ego effect when you found the Holy Grail, right? The Holy Grail of physics, the unification theory, right? So I found it. Joe Smuckhead outdid Einstein. Okay, something Einstein couldn't do, something Feynman couldn't do, none of these assholes could do, and I did it, Joe Smuck. So you can't help but have a little bit of an ego thing happen. To say it's meaningless, I don't think that's true, in the sense that this material description of reality is going to be even more decisive in terms of the determinism of the universe. It takes away all the wave mush. It takes away any hope of multiverses. All that crap they have piled into physics disappears. There's no reason for any of that shit. So I think it is significant in that sense. So I don't think it's meaningless, because it does give me more weapons to use in the argument that we're just stupid robots filtered out of a universe that made complexity merely because it could. What could happen, and it happened. Yeah. Anyway, and what drove me for this anyway was just the fact that here's an obnoxiously silly. It's like what you could say. What drives you to argue against theism? Well, first, it's a preposterously wrong answer. So even just because it's a silly answer, that's reason enough. And then obviously it's this implication that I think it does have meaning in terms of fucktard is fucktard. Once you get stuff wrong, then you start piling more wrong on top of the wrong stuff, and then the wrongness just gets out of control. And that's my argument with physics, is that it got way out of control, loop-de-doo, phantasmagorical, silly. It's leprechaun theory is what they were talking, and it was obnoxious to my sensibilities. It was obnoxious to be told I have to believe light is a wavy thing that doesn't, and the photon doesn't know where it is, and it only gets lost when it's in between where it left and where it's going. It somehow knows how to get where it's going, but it's lost while it's doing it. I mean, it's just silly shit. Anyway, this goes far past than just a hobby, and there is more passion in it than just mere glory. Well, I'm just saying, you know, I don't know, you know, the whole thing is public. So I'm just saying, if you go back to the original videos, the whole thing I was doing, I mean, even back to the original Emendum videos where I was arguing this originally. I mean, the point is that the silly explanation that photons split in half and go through both slits and then figure out how to do their probability math and then figure out where to land was just absolutely silly as an explanation. I couldn't figure out how adults would accept such a silly explanation. There obviously has to be some other explanation. And thinking about that just ended up me doing the gravity thing and turning it into a part of, I mean, there's a whole evolution here, but I'm just saying to say, why are you passionate about it? I mean, I mean, come on. It's as big as somebody realizing that, hey, maybe animals evolved. I mean, it's a pretty big realization, and I should, I think, be distracted by it. Anyway, a galaxy would act as a lens to passing matter by bending its course. So I've done videos on this subject. I don't need your instruction, douchebag. Okay, the physical fact is that you can't say there's gravity somewhere unless you explain where the gravity came from. Now, solar lensing, Einstein's explaining where the gravity comes from. Galactic lensing, you have a real fucking gravity problem, because guess what, jackass? In the far ends of the galaxy, there's very weak gravity. So how can you have a lens out there, jackass? And a very big lens, you know, thousands of light years of a lens? Fuckhead. Anyway, gravity can alter light by blue shift. Fuck you. That's idiotic. Why not bend it? Well, again, where did you prove that gravity alters light with blue shift? Where did you prove that? What experiment proved that? Oh, that's right, none. Although, and how would it blue shift light? That's even stupider. Okay, if it was going to do anything, it'd be red shifting the light. You know, preventing it from getting away. You know, therefore slowing its frequency down, its emission frequency. Why not bend it? Although it is meant to be massless. Well, again, that's not what Einstein is making it quite clearly. So unless you want to just say Einstein was full of shit, the very point is that obviously Einstein gave the photon mass so he could do the gravitational equation to have it bent by gravity. Something with no mass can't be bent by gravity. If you put something with no mass in the fucking equation, guess what? It's zero gravitational effect. Dumbass. I do not mean bent space. Well, it doesn't matter what you mean. I'm just saying Newton's formulas, no formula will work on a zero mass. So if you have a zero mass, you have no formula. No formula, no gravitational formula can be applied to a zero mass. So quite obviously Einstein gave the photon mass, and what he also gave the photon was extra time in the gravity. That's why he said solar lensing was possible, because by his theory, because by time dilation, it would end up that the photon would be in the gravity twice as long, and therefore it could be bent enough for us to see it. But if it wasn't in the gravity twice as long, yes, then there's no math that makes solar lensing possible. And as stated, it just doesn't matter, because quite obviously they have never repeated that experiment. So again, it's bullshit. He's not a UK guy, he's Australian. I mean, geez, you know, people just don't follow along. Anyway, I mean, I always point out by making some kind of joke, like, oh, he had to wash his koala bear. Or, you know, I'm always making some sort of Australian joke. I mean, fuck. But anyway, he even makes the Australian cracks. So anyway, Yeah. So look, it's okay if people want to make a comment, that's fine. But if you're going to do something like you're going to be a presumptuous asshole and assume I don't understand something when you haven't really watched more than this video or this conversation, yeah, see, that's insulting my intelligence. I don't need your instruction, fuckers. I mean, I'll bury you. So if you really want to have the contest, I'm just saying, if you want to engage me rudely, then man up, come into the room. Okay, I'll give you the link. Man up, and we'll see who knows what they're talking about. We'll see who's done the fucking research. Okay, we'll see who's watched, uh, who spent the last 4 years doing, spending most of his recreational time doing physics. Anyway, I'm so sick of pompous assholes who put nothing. Again, you got to put something on the line. All right. The truth is, I've been on YouTube for 10 years, and you're going to be hard pressed, in my opinion, to find out anywhere where I have been demonstrated to be fundamentally wrong in assertions I've made. Just fundamentally wrong. I don't make wrong assertions. I don't argue things that I'm not confident about. And, it's just bullshit for these turds to show up here and say, you're an asshole. Well, I don't even want to talk about smoking. Yeah, I would have done this so much earlier if I would have had real cigarettes instead of this cheap shit, right? But yeah, how much of who I am has been cigarettes. It is kind of a funny thing. I'd love, you just love to. I wish you could do it. I wish we had computer models good enough for this kind of shit. But it'd be just great to be able to punch your life in and just say, where would I be right now if I never smoked a cigarette? Or it'd be very interesting, to see just how what it really did to you. I think the argument against alcohol is kind of obvious. I don't think alcohol ever did anybody any good, or drugs. But cigarettes are really in a weird space. If they don't, kill you, it is an interesting brain drug. Are you saying there's no gravity in space between ground? No, what I'm saying is to bend light, you need a lot of gravity, a ton of fucking gravity. Okay, do you understand? Light is the tiny. Well, that's not even the point. It's not about its size. Light is moving fucking fast as fuck. Okay, so to bend it, to move it, you have to have a lot of gravity. And the gravity in the reaches of the galaxy is infinitesimally tiny. The sun's gravity where the Earth is 0.018 meters per second. Think about it. It's not even a meter per second. It's 0.01. It's like 6 centimeters a second gravity. You couldn't feel that. You couldn't even notice it. It's such tiny gravity, and that's where the Earth is. Pretty close to the sun, yet the real gravitational effect is minuscule. Yeah, whatever. Oh, finally a troll. Yeah, fuck you, son of a bitch. Put user in timeout. I'd like to put the user in a bucket of acid. See, that's what Google's got to give you some real choices. Put user in bucket of acid. Yeah, that's the one I'd like to choose. Yeah. Yeah, who knows? Who knows where you'd be? Maybe I wouldn't have gone neurotic and I still would be in the real world. I'd be working at some dopey corporation wearing a black tie and, haircut and all that shit. Who knows? I'm just saying, it is, all these little things that decide your fate. Little stupid things. But yeah, the space between galaxies is really low gravity. And I've made this argument before, but there's another thing. I mean, if you really understand how gravity works, it just doesn't make any sense what they're arguing. So, okay, they have a galaxy that they'll be showing you a galaxy this way. Now, all of the gravitational lensing pictures I've seen of galactic lensing have always been galaxies that are sort of this way facing you. Okay, the round wheel thing. None of them had been this way. And the truth is, this way means the light is in the gravity a tiny amount of time. Galaxies are flat. And so the light goes through and is a tiny, tiny, tiny amount of time, barely in the gravity at all. Where if the galaxy was this way, the light would be in the gravity the whole distance of the galaxy. So that kind of lens would be possible. A galaxy this way, you could say, well, the light's going to be in that gravity for hundreds or thousands of light years. So it would make sense that, that maybe it could get bent if bending was possible. Like I said, I don't think bending's not possible, but regardless. So even their own physics doesn't make sense. All the galaxies this way, we should be seeing lensing on these points, a lot of it, because that would be very long in the gravity. Lots of bending possible if bending was happening. This way, like I said, barely in the gravity for a day. Not nearly enough time in that weak gravity to bend light. How long does it take light to traverse a galaxy? Well, like I said, it depends on the galaxy, right? They can be hundreds and thousands, and I don't know if they can be a lot of light years across. So they can be like, 1,000 light years, I think. I mean, pretty far. So it takes 1,000 years for a photon to get across the galaxy, or it could take 10,000, I think. I mean, it's big numbers like that. So galaxies are really fucking big, really big, but they're not solar systems. So you have to recognize too that their mass isn't in the center and all that kind of stuff. It's in the arms, and you just can't create whatever you see as light would have to be the lens. The flare has to happen in the actual lens. So if you see a blob of light, and they're calling it lensing, it means the heavy gravity that bent the light has to be along that whole length. So that entire length has to be heavy gravity. It can't be speckled with the little stars and stuff. It has to be, all of it has to be heavy gravity. And that's obviously silly. The universe itself is bent. Fuck you. It's just, okay, you say so. Oh, gee, the Christian says so. Fuck you. You got to do better than that. That's just a nothing comment. I mean, I'm not going to block you, but I will delete just rubbish. I mean, you have to actually back something up. You can't just say something. Say, oh, I just said it. There, it's true. You have to explain how that's true. Show me bent space, retard. Show it to me. Show me an experiment that proves bent space. Yeah, so 100,000 light years, just, it's that's a big motherfucker. But the Milky Way is a big galaxy. It's not it is in like there's not too many galaxies, or, I mean, by proportion, it's only like 3% of galaxies are like the Milky Way galaxy, where they're really big and spiral and blah, blah, blah. Yes, coffee is good too, but I wish I never drank coffee, frankly. Cigarettes, I'm like, yeah, I like cigarettes, but coffee is just a silly, stupid. The whole caffeine thing was a mistake. Ruined my teeth, I think, mostly. As I didn't drink coffee for the first 40 years of my life. I never touched coffee. I mean, I had coffee ice cream or something, but I Never drank coffee. I did a little bit when I was working in a restaurant. No, so that's not true. So yeah, I did drink coffee when I worked in a restaurant, but I didn't drink it for 20 years in the middle of my life. And then I started 10 years ago, and that was just such a mistake. It's just crap. Yeah, I mean, it just kind of owns your metabolism, right? So you have to just accept feeling like crap for, a month to get off of it. It's just really irritating. Headaches and, yeah. I mean, I tried taking caffeine pills, but it really wasn't quite the same. I mean, your body metabolism just gets used to all the, whatever the little chemicals are that's coffee. Your system just kind of says, I want my coffee and I want my caffeine, and this is what I want for fluid. So I drink like the cheapest, crappiest coffee just to, try to make it as obnoxious as possible. So I'll be less and less likely to drink it. So I do try to make it kind of, God, that's crappy. Yeah. Yeah, well, some porn is good, right? You have to definitely have knowledge of porn. So you have to have enough, you have to watch enough to have knowledge of it. I can say that I got sick of porn relatively quickly. There was like a year where, yeah, okay, blah, blah, blah. It's like I was sort of into it. I mean, it would always be part of my fantasy function. I would associate with it in a friendly way, or however you say, I would jerk off to it. But yeah, then I just all got kind of samey. You're just like, same shit, different day. And you're just like, no, I'll just use my imagination. I just make my own little people. It's just, so I found it more fun just to make up my own little stories and adventures, and fuck watching some guy with a bigger dick than me having fun. That's no good. And chicks I'll never have. So yeah, porn just became kind of like, well, this isn't doing my ego any good. I drink a little coffee now more often, but only because I finally quit soda, which was even worse. Yeah, well, soda is, that will kill you. Well, not really. It will preserve you, actually. My neighbors drink nothing but soda for their whole, and they're still alive. The old dirty, stinking cockroach people. And you're just like, how can they be alive? It's just not possible. They eat absolute shit and, drink soda and wash it down with soda. And you're just like, how are they alive? But, they're, I mean, the kids aren't that old. They're only in their 40s, and they look pretty much morbidly soon to die. The adults are only 65. So, yeah, I don't think they're going to live to be 80. Anyway. All right, playing video games was a mistake. So much time waste could improve in so many other avenues. So, yeah, well, some video games, though, I think are kind of, the puzzle solving games and that kind of stuff. But yeah, just shooting up stuff is kind of useless. But it's so addicting and it is time consuming. So that part of it, I had to quit just because I was realizing, it's a perfect, fun game to play. You know what I'm saying? I mean, it's just this challenge. Can I do it quicker this time? Can I kill it without getting killed 600 times? Or, that whole, I mean, when I think about it, how many days it took me to kill that giant spider thing in the end of Tomb Raider, the original Tomb Raider. So I was like, this is an unkillable monster. And it just, you're just spending so much time, investing so much time figuring out how the hell do you kill this fucker? And, until you figure it out, it just takes forever to figure out that, oh, okay, I have to figure out how to jump backwards a lot. Yeah, I have to become a really good jump backwards-er, because, yeah, that's the only way to do it. Anyway, a galaxy is lens-shaped with the center of the densest, in terms of gravity. So face it would act as a lens on anything influenced by gravity. Oh, I'm sorry, that is just too incoherent, but I've already explained it. I mean, you can't explain any simpler. This is tiny amount of time. This is big amount of time. I'm not going to do that again for you, fuckhead. Slow ass nigger. Well, that's a good remark from the Christian Scientist guy. It's obviously a fake namer. Yeah. Yeah. So yes, I hope God properly dumps you in a bucket of acid and such. Uh-oh. Yeah, that was the right guy. Shit, almost killed Sid. Sorry, Sid. Yes, Sid, you were right in the middle of a bunch of Christian Science links, and the link was popping all over the place. You almost got killed. Almost died. This is dangerous. The whole blocking thing. So anyway, I think I will migrate to the next adventure in this thing called my life, and just never ends. Oh, fake sake and Jesus Christ! He made a video of some kind. I should have seen it, but I guess I don't know what happened. Maybe I'm not. I don't know. Maybe I'm not subbed to him or something. I don't know. But well, it makes sense. He's a fake sig and an idiot. Yeah. So what can you say? Oh, I love my guns. Yeah. So bad. So anyway, oh yeah, that's right. I was done. Yeah, it just bothers me. It's, I mean, fake Sagan. It's he's just the revolutionary, right? The anarchist voting for the billionaire. Just they're just all so fucking stupid. Well, that is just I don't know what the whole Hillary agenda is, but obviously she's likes making money, and that's part of it. And I mean, she's definitely associated. She has strong connections to Israel and all that kind of stuff. So I guess that's why we got to play the Middle East game. But yeah, I don't know. I don't understand the whole Democrat for war thing. That just doesn't work for me at all. Nope. So I hope she gets impeached. I mean, I hope she gets elected, and I hope she gets impeached. Yes, it is true. It's very hard to justify tormenting yourself trying to eke out a living. But I guess I mean, I'll be honest. If things get bad enough, I'm getting the fuck out, and that would be kind of cowardice of me, and all that kind of blah blah blah. You should stay here and fight the fight. But yeah, it's hard. I'm uncomfortable a lot. Yeah. My whole life has just been struggle. Oh, all right, that's cheating. I mean, I have been very lucky in the sense, that's the disgusting part, is that I consider it to have been much, just excessively brutal. And, I've had so much more than so many other people have had in terms of moments in the sun kind of crap. I have had my share of splendor in the grass and whatnot that other people never experience. So, but also, most people don't think much, so they don't get tormented by realizing what kind of horror they're living. I mean, this is a Freddy's nightmare. So, I mean, anybody who's having a good time ain't doing it right. This is Freddy's nightmare. I mean, this is bad shit going on here. Very bad. Every day, it's just every little photon is a tortured animal. I mean, there's just so much pain and fear and terror and suffering. Just awful. Yeah, it is funny how though I backed into a brilliant life, right? That is so funny because I would have, I figured I was just a piece of sewage. I'm just not gonna be able to make anything. I'm not gonna be able to recover, so to speak, my useful dignity, and I'll just have to accept that the world would have been better off without me. But it turned out different. I happen to be somehow, yeah, somehow I did it right by accident. Did it right all the wrong ways. So it was quite necessary that my life was a failure because that was the only way I would have done any of this shit. If I would have been successful, then I would have got all caught up in the bullshit. Would have fucked all the wrong women, acquired all the wrong diseases, and horror, horror. So, being a neurotic lunatic just happened to be the right strategy. Yeah, well, look, Snake Plissken survived, so you gotta give him credit for that. But yeah, he's got himself, I feel bad for him because, it's tough starting over. I mean, rebuilding a life every 5 years is no fun. So, and I bet he's getting awful tired of it and gets harder each time. So, but maybe he'll fall into some, I mean, he's a smart guy. So, I mean, theoretically, you think he might be able to get a good job, but it's a tough market out there. I mean, you got to get really lucky. You got to find some, I mean, you got to find some Trump or something, some, person that's just dripping extra money, where you can actually get some kind of, get lucky. And, well, talking about how sexy my penis is, just probably, even though that's kind of nice, it's still probably going to get you blocked. Yeah. Anyway. Yeah, probably. Seems life is much kinder to the unkind. Yeah, well, I don't think it's much kinder, but I mean, it does beat the shit out of even horrible people. They all get Alzheimer's or something, and spend decades in wheelchairs, and all kinds of shit happens to them too. But there's definitely not enough deserve connected to any of this shit. So play by the rules, and you get your ass handed to you. Cheaters do win, that's true. But I mean, the end game is the end game. I mean, nobody wins at the end game. I mean, unless you're lucky, right? You just drop dead of a heart attack. But I don't think there's any correlation between good people and bad people being tormented to death. Although there might be in a relationship, because the better care you take of yourself, the more likely it is you're going to live long enough to get all kinds of diseases and survive them. And the worst, you take care of yourself, the more likely it is the first disease kills you. So yeah, it might be a better strategy. Yeah, it really is you know, gosh, you can't. I mean, it's just you can't even find can't even simple things like selling shit on eBay, and you're just like, oh fuck this, fuck this. Everything sucks as a choice. It's just oh, working at the diner. Oh, great. No, thank you. Yeah, well, the Mexicans are pretty good at, having no life also. Well, the South Americans generally, I'd say the South Americans more than the Mexicans, but, some of them are, you know, they're just so used to no life, that they can work 15 hours a day and say, oh, yeah, I could do this all week. It's like, yeah, who wants that as a life? Get up before the sun's up, drive a silly distance, hammer shit all day, go home, eat some food and die, and then do it all over again the next day. I mean, I just don't know how people do that. That's horrible. Yes, it's a miserable circumstance we exist in. Very bad. Idiocracy is rolling over us. I can feel the weight of the water-filled barrel smushing my organs out of my mouth. Anyway, enough. I've done enough little extra babbling here that's not relevant to the important subject matter and such. So anyway, till maybe tomorrow, or the next day, or whatever, I have to do some rewriting, so I should do that. And I just have to do the pictures. So I got to do this proton electron picture in some sort of really good way and put that on the website and such, and make animations, and I just so much to goddamn do. I still got to crawl into my house one of the next 2 days. I'm supposed to have some good weather, so I have to finish under there. And then I have to go up in the attic. No, I just don't want to do any of this shit. I don't wanna. I'm in such a God. I'm in such a I don't want to do anything mood. Everything appears to be work, and I'm getting so tired of thinking, doing. Just want to watch movies or something for a month. So, but anyway, go, do. My new motto for the next 10 minutes, until I get a stomach ache or something. Complain, I can't do it. Yeah, I'm too tired. Yeah, well, I've done it before and come back, so I can recover from indulgence. And movies ain't what they used to be, right? So movies are pretty fucking irritating now, right? It's just plot flaw after plot flaw after plot flaw after plot flaw. Yes, I'd love to be Spock. Well, see, Spock wasn't even a good Spock, though, right? This Spock was always angsty and like, I'm repressing my emotions. I'm fully in control of them, mostly. So, God, I hate that fucker. I mean, he was a bit of a fucking hysterical girl in some respects. Yeah, really was. They've kidnapped the captain. What do we do? Oh, wait, I'm Mr. Spock. I'm supposed to have the answer. Let's hysterically overreact. Like, we don't really need the captain, do we? Oh, I can be captain. Yeah, it just didn't seem very Spocky to me sometimes. Jim. Fuck that shit. Anyway, so Spock wasn't very Spocky. And the last Spock was just the worst one, right? When Vulcan got blown up, you're just saying, oh, so Mr. Spock, you're not really Mr. Spock, right? You're just a bigot like everybody else. Like, you think if Vulcan doesn't exist, the whole universe is going to crumble. What is that bullshit? I mean, why are the Vulcans more important than the other people that got blowed up? So I'm just saying it seems a lack of discipline was applied in Spock's logic there, in my opinion. So yeah, Spock wasn't a good enough Spock. But if they made a real Spock, he would be like, let's just drive the starship into the sun and just fuck this whole nonsense, right? This is all a bunch of, this is like anal sex or something. People are just not even doing it right at all. We're just bugs. Why are we pretending we're something else? Fuck it. Just drive it into the sun. Fuck this bullshit. Pretensive nonsense. So, yeah. Yeah, I mean, really, if you're going to be purely logical, you just can't come up with any excuse for making messes and then cleaning them up, right? I mean, that would be what Vulcan would figure out. Oh, well, don't make a mess, then you don't have to clean up a mess. Okay. All right, let's see if we can apply that to the world. Oh, yeah, it looks like these are all unnecessary messes. So, no necessary mess, then, yeah, I guess you just make it all go away then. Yeah, Ethel Star Trek. Oh, woe is me. We're going into space. Oh, God, there's going to be all kinds of terrible things. Oh, we got to go eradicate everything. Oh, fuck. Why is this my job? Oh, God. Can't we just make a machine that does it? I mean, I'm just mean the the human having to be the Terminator is just such a hard mix, right? It's just, even the Terminator couldn't be a Terminator, right? Even the Terminator got kind of egocentric and, oh yeah, you fuck with me, well, I mean, you could just, they could see ego running in the Terminators. Even when they were doing their Terminator thing, they seemed a little ego driven. But anyway, it would be a great. A real Vulcan would be just an interesting, that whole idea of the purely logical thing, just forcing you to accept your bugs. What's your counter argument? Okay, come on. What? Explain to me how you're more valuable than the non-existent Martians. Okay, explain to me why you've never lamented the absence of the Martians. Why don't you just explain that to me? And when you've explained that to me, then I'll give you permission to talk about how you're doing something important. But until you explain to me why you've never cried one fucking tear for the non-existent billions and billions of Martians that could be existing. Yeah, so that would be interesting. Yeah, like a real logical person interrogates Mr. Spock. Yeah, just proves him to be you're just silly, right? Yeah, you're just silly. I can, yeah. Anyway, enough of that. It's almost sciencey, though. Let's see. People do cry tears via literature. Well, I'm just saying, where's the literature on how? Oh, it's just so sad that there's no Martians. Oh, think about all the butt fucking they're not doing. Oh, it's me. I don't see any. Where's that literature? Idiot. So anyway, yeah, I was leaving, and now I'm going to leave again. Some more. Yeah, I'll continue to leave for the next half hour. It's one of my best performances, right? Yeah, I should do like a Broadway play of it's over, and I'll just, be walking off stage for the entire performance. Yeah. Sleeping less, working more is a really good tool for passive suicide. Yeah, well, I don't know. It works both ways. I mean, sometimes it's good to get caught up in something mechanical and physical, and it distracts you, and so it does. It's almost the opposite of suicide. You get back in the game a little bit addicted, a little bit of your blood gets moving, and you get stimulated. But yeah, it works the other way too, right? So. Yeah, I'm just currently in not a great place. I can't get, my routines are not routine enough. I like routines. My routines are kind of broken. But anyway, now I'm leaving this time. I'm going. Oh, MIC. See you real soon. FWK. Fuck it. Yeah, shit. Fuck shit. Gobbledygook. And such. Anyway, oh, this guy's going to say something scientific again. What is pushing a galaxy towards its center? Well, I'm just saying there is a center, but I'm just saying if you have two arms that have equal mass on opposite sides, those two arms are pushing each other towards what you're calling the center. But I'm just saying they would be pushed by their own mass. So I'm just saying can't think in terms of like solar system mechanics. So if I took the sun out of the solar system and I replaced it with a second Earth and a second Venus and a second Saturn and a second Jupiter, exactly the opposite location, you could almost imagine that even if you just shrunk the solar system in size a little bit, that would work, that the two Earths could rotate each other. And so that's more of the mechanics of a galaxy, is much more of the mass is in the arms of the galaxy than in the center. But anyway, I want to explain all this stuff over and over again. I mean, the suns in the galaxy, ironically, are probably moving faster to the center of the arm than they're moving to the center of the galaxy. So there's probably more gravitational pressure to move towards the arm than there is to move towards the center. That's why I don't think they have the red shift numbers right, because I don't think they appreciate the fact that the sun is not moving towards the center, it's moving towards the arm. But anyway, I'm going 30 minutes later, I'm going. Yes, well, now maybe I'll say I'm leaving now. So I'm going to leave now. So we'll see how that works. So this is the leaving process. 10, 9, 8, 3, 7, 6. I'll use up all the numbers in my own way. Darwin's hammer. I don't think that's correct. I like the website you have dedicated to your home production porn. You hot as fuck bio. Whatever that is. But anyway, quit using other people's name. It's rude. You nasty person. All right. So you accept the push must be coming from outside the gravity. The point is, I've just said, is the field energy is outside of everything. Everything exists in the universe. The universe is full of quanta. The quanta create the pressure that holds everything together. So yes, gravity is a push force, not a pull force. Push, 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 push. Push is simple. Pull is complicated. Push is easy to understand. Pull is not easy to understand. All right, so that's enough. I've already been over this shit. All right, till next time, and such, so forth, and whatnot. Now I'm going to hit it. Yep, it's going to happen this time.